name is Krishna Prasad and I am the project leader and prototype builder of this CAPSTONE project. I'm responsible for overseeing the team's work and ensuring the successful development of this prototype, including its coding and functionality.
Hello, my name is Devarjun. I take on the role of marketing and communications leader as well as information research. I consolidate the project logbook, prepare content for the video clips, and conduct in-depth research to ensure the team has the information needed to make data-driven decisions.
I'm Jeff, the designer and the video producer. My role focuses on creating a seamless user experience by designing process flow and the user interface for our prototype. Additionally, I document the team's progress and produce the final video presentation and showcases the work.
I'm Jacinth, the data expert and tester. My primary responsibilities include collecting data and managing data ethically, training the AI model alongside the prototype builder, and thoroughly testing the prototype with users to ensure its accuracy and reliability. I also create action plans for areas that require refinement. Thank you.
Now let's take a look at the coding part of this project. First, we get the data set from Kaggle, which in this case is supermarketsales.csv. Then we make them into two data frames. Second cell, we find the information regarding the aforementioned variables, like if they have nulls and what their data type is. Here we can see that 5 of them are object type data types. We use dot value counts to analyze these data types and find what their categories are. In the variable city, there are 3 cities. In the variable gender, there are 2 genders. In product line, there are 6 product lines. And there are 3 payment methods. Since a regression model cannot use categorical data types, we have to change these categorical data types into numeric values, into numbers corresponding to each category. Then we inspect the structure of this change data set, which has no object type data types. Then we pip install a module called Y-Data Profiling, which will later help us understand our variables. And in this part of the code, we are importing cbourne as SNS, then reading data.csv. Then we've used .core to find the correlation between each variable in this CSV file. Then we use a heat map to visualize this. Here the correlation ranges from -0.1 to 0.1. Then we use the before mentioned Y-Data Profiling, which we pip installed. As you can see, it gives us the information regarding the data set and information regarding each variable. You can see the interactions between each of these variables using a graph. And using this part of the Y-Data Profiling, we can see that none of the variables have any missing values. This data into training and test set. Here the test size is 0.1, which means that 100 rows will be used as testing and 900 will be used as training. We import a linear regression model from sklearn.linear model. Then we use model.fit. In this next part, we use a trained model to make predictions. Now we check the actual and predicted and see how they differ. Then we find the mean absolute error, which in this model is 50.5. Here we are manually finding the RMSE and MSE values of this model. Here we can see that the RMSE value is 70.9 and the MSE value is 5027. Then we find the R-square score of this model, which is 0.924, which proves that this model is quite effective. Then we use matplotlib.pyplot to visualize this model and its accuracy. Here we can see that most of this prediction fit the perfect fit. The data given by the user to figure out the sales data. As you can see, the model has predicted that you can gain 97 profit. So using the next part of the code, we can figure out the unit price that we should keep to gain maximum profit. Here we can code in some cases we might get a negative profit, which is the new unit price, which will be less than the unit price we were given. But with this unit price, the user is more likely to buy the product.